So I'm going to talk about high-level incentive problems in the Lightning Network. Um, so the first thing to think about is that we have two different mechanisms for making Bitcoin and Lightning work. And one mechanism is like math. So if you do a SHA-256 of something, you don't have to worry about incentives of whether that's going to match to, the expected result. There's no incentive there. So the problem is we can't build a system that is completely based on math. We need to. That's a problem that started with the Bitcoin solution, that we're going to introduce this kind of workaround for determining to prevent double spending, and we're going to create this incentive system to prevent that from happening. And if we could come up with a totally logical mathematical solution, we should instantly get rid of this proof of work incentive system, because like a logical solution would be better. So like the more incentive based it is, depending on the strength of the incentive, it becomes weaker if it's just incentives and stronger if it's more math based. And in Lightning, we really have to think about like a lot of different incentives, and we have to think about them from like two sides. So everything has like a cost or a benefit, right? So in Lightning, like as an overall network, we have all of these different components that we're introducing. So we have these CSV delays, like how long before I get my money back, and that could be also the CLTV delays. We have hardware costs of like running a routing node. We have capital costs of funding channels with people. So we have chain fees. Like in order to create channels, you got to pay a chain fee. Tear one down, got to pay a chain fee. And then we have to compare those kind of against the benefits. So like the number one benefit maybe is I get to buy stuff. So that's pretty cool. But I also have some kind of other benefits, like if I'm a routing node, I get some routing fees. Or capital itself being allocated is kind of like a benefit. So if somebody's allocated a lot of capital towards my node, I now have like the ability to receive. So that itself is kind of like an asset. And it could also think about it in reverse. So I've assigned my capital to very good nodes, and now I have great outbound liquidity. So that's also kind of an asset that I can acquire. And there's this trade-off between the costs and the benefits. And then there's some things that are kind of like in the middle. So there's like altruism. Maybe I just want to support the network. Maybe I just want to play around with it, see what it's like, or gather data, or maybe build myself up for a future where I anticipate I'd get more benefits. So the number one incentive to think about, like the key incentive problem I think for Lightning, is this capital requirement. So just to like narrow down on it, I have this capital cost. I have to get the money. I have to kind of put it out there in an addressable node. I have to rent this node. I need to pay chain fees to establish my node, and then I can get some specific benefits from that. So I can maybe get some data about how well are my payments succeeding, or how well am I routing. I can get that fun. I can get that good experience of like operating a routing node and like seeing if I can route the most payments of anybody in the world. And then I can get directly paid. I can maybe sell my capital, so people want that inbound liquidity. So I can just like kind of say, this month I'll assign my capital to you. And then the normal benefit for your capital cost is that you get to buy stuff. So I want to kind of drill in on this problem of capital assignment, just to like highlight all the problems with capital assignment. So I make a channel with somebody else in the network. So we have a system where we have a unilateral funding. So whenever you create a channel, the funds start on your side, and then they can flow over to the other side. And just very basically, like what would happen if we had a system where everybody could equally contribute capital? Well, somebody like LM Big could come in and just like get all of the capital from everybody in the network allocated to him. and that might not be optimal. That might not be what actually people want to select. So unilateral capital assignment gives people a lot of control over like where they want their capital to be assigned. So here are some problems like with even opening up a channel to somebody, why you wouldn't want to do it. So more capital, like opening up a channel is, there's a certain amount of capital assigned, like a certain amount of Bitcoins. And the more Bitcoins you have in your wallet, the more risk there is that something goes wrong in your hot wallet. So there's, just some risk factor there. Whenever I assign, so let's say I have 5 Bitcoins, and I take one of those Bitcoins and I assign it in a channel towards you, and you go offline. So now, actually, assuming we're all networked together, only 4 of my Bitcoins are now spendable. So I have some risk that you reduce the utility of my coins. Another problem is, there's a marketplace kind of developing for this liquidity. So I have 5 Bitcoins, and I assign it to 5 different people. But then I notice, oh, there's people paying for this liquidity. So you're not paying me anything, and somebody else over here is paying something. So why don't I bring down my channel towards you who are paying nothing and assign it over to them, and they'll give me some money. So there's opportunity cost to assigning this liquidity. And that applies even if you don't assume this capital market for people who are willing to pay for channels. You could say, well, maybe I could get better routing fees somewhere else. You're not really using this channel. And that's actually kind of like the healthy mode of the network, is that people are somewhat assigning capital in somewhat the correct positions for payments to actually move across those. And then I also have another problem where if you go offline and then I need my money back, I potentially have to wait for a time lock period. So some percentage of my coins, I have this risk, maybe they're going to be locked up for weeks potentially. So these are all the reasons why you wouldn't want to assign capital to somebody else. So it seems like we have a good solution in this unilateral system where you choose who to assign your capital to. So other people can't just come and introduce these costs to you. You have to like take on these costs yourself. But if you think about people who have routing sinks, who already have some inbound liquidity, or can deal with somebody else who has inbound liquidity, every channel that you make every time somebody makes a channel with you, even though you don't have your funds the funds are not on your side, so you don't take on these risks in the beginning. If they pay through you to somebody else, now the funds move to your side. So actually, even accepting channels from other people can introduce all these risks to you. And your defense against this is to set a routing fee, basically. You don't have to let them move all the funds over. So but it's something to think about, because the default mode right now is to just allow anybody to connect to you, assign capital, and move their capital through you. And there's not a huge amount of sophistication about that right now. Okay. So another thing to think about, like that's fundamental as an incentive problem, is that Lightning really depends on the layer 1 security model. If layer 1 security model fails, well, all the assumptions that you made in Lightning don't work. So we have kind of like these, all these time locks, right? So like, let's say somebody broadcasts an out-of-date state of the channel. We have the assumption that, oh, there's a certain amount of blocks that I can have, and I'm going to be able to broadcast this justice transaction, and that's going to move the funds back to me to punish them for broadcasting this out-of-date state. But in Bitcoin, or any chain that can be reorged, you can actually remove transactions from the chain, and this especially applies to if you're trying to deploy Lightning on a weak chain. So there's certain chains out there where you can carry out very long reorgs. So if you're not careful with your time locks in your construction of your channels, and you say, oh, always after 6 confirmations, it will never be replaced. So just make sure that I have 6 confirmations to do the justice transaction. Well, on a lot of different chains, there's not enough proof of work to make that very secure. So you could potentially lose money just based on the layer 1 assumptions being broken. Another fundamental risk and benefit to think about is when you're forwarding transactions on Bitcoin, which is an expensive network, every HTLC that you get in, it's a potential contract that could go to chain, right? That's how you could get that money if something goes wrong. But the going to chain actually has a cost. So, and you actually don't really know who you're dealing with. So you don't actually know the source of somebody sending you an HTLC. Anybody could have been the originator of an HTLC to you. So you get in an HTLC, and maybe it's for 150 Satoshis. And you say, oh, well, 150 Satoshis, I'm going to charge 1 Satoshi. You know, I'm a nice guy. I'm not going to charge too much in routing fees. So you charge 1 Satoshi. And then what happens is this HTLC, something goes wrong down the route, and maybe your peers go offline or something. So you need to, at this point, you need to go to the chain. Maybe they go to the chain. So technically, like, you're still covered, right? Like there's incentives. Like, it's not like they can just arbitrarily take money from you, but there's all this hassle of going to the chain. The channel's going to be dead. You're now going to have to sweep this out and move it into a new channel. So there's a lot of costs associated potentially with any HTLC that you move along. And what's the benefit? The benefit could just be 1 Satoshi. So you want to be careful about how you structure those incentives. So like maybe you want to set up on your node like a minimum amount that you're willing to send, a minimum amount of fees to justify it. But there's this risk. There's this fundamental risk here, which is every time you send this route, you're taking on this kind of risk that it does go to chain. You have to pay this cost. In practice, I don't think it's a major deal because of the incentives. There's no huge incentive to make it fail, but it potentially is a problem. Yeah. Reputation is difficult with this because you don't know who the sender is. But definitely, like, if your peer closes, right, and you can kind of think, oh, they did something wrong. In that case, then you could say, I'm going to avoid talking to them again. But they could also spin up a new node. So it's just a fundamental problem to think about. It's a limitation. Okay, so another thing that's to think about is it does get back to this reputation question. So every time you send out a payment, you send it out on the network, and it's all encrypted and stuff. What happens if the payment fails? If the payment fails, there's a specific point in the route where it fails, and then it fails back to you. And what's included in that message is like failure reason, and it includes kind of like the originator of the failure. So I know kind of like where it failed. I have like an idea of where it failed and why it failed. And so what we do with that information is we use it to try to when we choose the next route. So we try a route and it fails, and then we try another route and it fails. And if the target is not well connected, you could try 100 routes. I think by default we'll stop after like a minute of trying routes. But one thing to think about is these errors are kind of like voluntary. So they're more for debugging than they are for like as far as modeled after incentives. And in the spec, there's not even really like a thing that you definitely have to do when you receive these errors. It's kind of like your own choice. How do I want to react to this error? So we need to think about like the incentive to return a correct error, because maybe the node is going to lie. And so an example of that would be like, let's say that there's a fee insufficient error. So a fee insufficient error means that, oh, your routing fee is too low. I advertised a fee of $1, and you gave me 50 cents, so I reject it. But which side is at fault? Maybe the sender, maybe they didn't send enough money, but maybe the receiver, they were like, saying that they're contradicting their own advertisement, maybe, or you didn't see the advertisement. Um, so it's hard to know who's at fault in every single situation. And we have to think that if we develop the pathfinding logic, that we don't want to incentivize people to lie about what happened, to try to like cast the blame somewhere else. You know, maybe they're gonna like, maybe they're gonna blow up the error. They're gonna say, I don't want you to even really have an idea of like that I had anything to do with this error, because I want you to try me again in future payments. So we need to be careful about like how we implement this pathfinding, which can vary from wallet to wallet and isn't really specified. Okay, so Watchtower is another interesting like incentive problem. So that's something that we've just rolled out. Is in L&D we have this Watchtower feature that you can turn on, and it's designed to work against your own node. So we call it altruistic Watchtowers. But if we wanted to make it work on a non-altruistic mode, so let's say you set up a nice Watchtower to well, let's say you tried to set up the altruistic Watchtower as is right now on the network. What could happen to you? Well, the way that Watchtowers work is they are kind of like they're holding these justice transactions in reserve. So whenever they see something funny go on the blockchain, they decrypt their store of justice transactions, and they say, okay, it's my time to shine now. I'm going to help you and broadcast this justice transaction that I've stored up. But that means that you're actually having to give them these justice transactions. So they're building up a database of more and more of these justice transactions, and they're scanning the database. They're scanning their database versus the chain to see if there's any unlock keys that can unlock this justice transactions. But each transaction is like a real transaction. It's a Bitcoin transaction, so it's maybe like 200 bytes or something like that. So every time if you just opened up this altruistic Watchtower to everybody to use on the network, unless you got some kind of identity from them, they could just give you tons and tons and tons of different transaction states, and you don't know if they correspond to anything, because every time you do an update with the channel peer, you're generating a new commitment transaction. So you're generating a new potential justice transaction. So that's kind of the problem with just doing completely altruistic Watchtowers that are open to everybody. So we need kind of like an incentive model to say, why should I have this database that's being filled and filled with more and more of these, somewhat small transactions individually, but potentially millions of transactions. So there's two kind of reward models that I've heard about for Watchtowers, and one is that you could design a Watchtower so that if there were a breach, that one of the outputs would give the money to the Watchtower. So that would kind of like be an incentive to be a great Watchtower, because like the way you would get paid is by doing your job of like punishing the people who, who are trying stuff. But it's complicated to do it, and the bigger problem is there's hardly any breaches at all. So like my node has had thousands of channels in its lifetime, and the punishment for breaching is so severe that, and the benefit is so limited that potentially, but it's just at the moment it doesn't seem to make so much sense, because there's just not that much breaching going on. So another model for Watchtowers is more like what we're going along the lines of, is kind of just having reliable Watchtowers that I just pay them for kind of like their space and their time. And in that system, it can still be fairly private. So we can use kind of like blinding signatures to generate, like, so that you can't like keep track of who I am. And that's pretty important if you just have like these broad Watchtowers to the world, because you don't want your Watchtower to know that to be your peer as well, right? Otherwise, it's watching itself. So that's what we're thinking about as far as to deal with the problem of like, why should I run a Watchtower for people? Is that you would pay it. Okay. I had like a bunch of grab bag problems, standard problems. Um, so one issue in the current network is that, so if you think about routing nodes as if they're like service providers, um, they actually, routing nodes can have two types of customers. They can have a customer who is like a mobile wallet, and this mobile wallet is kind of like one-sided. I can't really route through them. And then I can have another type of node connection, which is like another routing node. And that another routing node, I can route back through them. So if I receive money, I can push it out back through them. But in Lightning, we only have one type of fee. We have a type of fee that applies outgoing to through a channel. We don't have a type of fee that's based on incoming. So whenever one of these private channels who could potentially take my money offline, who potentially is not doing, I can't, they maybe have to pay a chain fee to get it back. Whenever they use my liquidity, they pay the same amount as that very well connected routing node that I can always pay through them to go. My connection to them is worth a lot. Is always available. I'm not going to go to chain. Maybe I have a long-standing reputation with them. So we have this. We have kind of like um, a missing piece in the fee in the way that fees are described.
Why? I mean, you'd have to gossip more information, obviously. Like, you have to gossip all possible combinations between this outbound and inbound channels, but it's not impossible, right?
Yeah. It makes more sense to start simple, and like if you added pairwise fees to every set of peers, maybe to every set of channels, you'd have an explosion. So just something we have to think about. And maybe another solution is like you have one type of node that talks to all of the that. So we're working on this thing called channel acceptance policies, because you don't have to accept a channel from anybody. So I could say I had two types of nodes. I have one type of node where I classify all of my inbound to be the same type of person. So it makes sense then that they have all the same type of outbound fees. And then I have another type of node which has I only allow channels from people who are well connected, and then I charge them a different class of fees because the liquidity is worth a different amount. It's just something that we have to like think about, like more as there becomes more of this differentiation in the network. If this happens. Okay, so another issue that's being worked on is that so the way that fees are paid, like chain fees are paid. Let's say I want to close a channel, and we talked about this before. Like I have a channel with you, and you initiated the channel. So maybe I went to Ellen Big and I said, Ellen Big, please give me a channel. And Ellen Big opened up a channel to me. So now I want my funds back. I want to get my funds back on chain. So let's say I want to get them back right away. Well, I have all the cards here because they, as the initiator, are paying into that commitment transaction fee. So all I really need them to do is to broadcast that commitment transaction, and then the funds go into the remote output, and I can spend them unilaterally. So maybe I can negotiate with them. So I can say, let's cooperatively close to be cheap. But I'm in a really good negotiating position because all I have to do is get them to broadcast that commitment transaction. So in the future, this will be like addressed to some degree with the addition of time locks on both sides. So right now, the remote output doesn't constrain your funds. It just says, oh, go to a standard key. But it's something to think about in the current setup. Maybe Ellen Big should think about that. Okay, so another incentive problem. I think I talked about this. I'll talk about this in more detail. But failures are free in the network. So if I send a failed HTLC through you, that consumes some of your, that's a cost to you. You have to lock up some of your funds at some point. You have to update your commitment transaction. You have to hold one of your output slots open for that HTLC. And then if it fails, what did you get out of it? You got nothing. because you only get paid on the routing fees when the payments succeed. So in Bitcoin, we have this mechanism where you always pay if you broadcast. So if something if something enters the mempool and is a cost paid by somebody else, they have to pay that fee. Otherwise, they're not allowed into the mempool. That's like how the mempool fee is designed to work. But we don't have the same concept in Lightning at the moment, which is if you do something, you always have to pay for it if you incur cost on somebody else. Okay, so another thing to think about is that we have this method of backups called static channel backups in LND. And the way that it works is you retain a file that is updated whenever you make a channel. And this file contains like information about how to get back in touch with another node on the network. And the idea is if you lost your entire database, you lose all your information. But you still have kind of like this way to get in touch with the peer and information about the channel that you could reach out to them. And you could say, listen, I need you to force close. Because they're going to have the latest up-to-date version of the channel. And you could say, I need you to force close this channel. And also, so once it goes back to chain, I'm going to be able to use my mnemonic plus this. You're going to supply me with a little bit of data about the to remote output, or just a general commitment transaction that is going to allow me to sweep all my data back, sweep all my funds back. So that's how our current system works. So if you lost your database, as long as you have the channel backup, and as long as you can connect to that peer, and the peer is complying with the data loss protection protocol, you can use that information to sweep back your funds. But there's certain problems with it. So one problem is that they could use that information that you have bad data. Say maybe I'm going to try to breach you now, potentially. So we could kind of counteract that problem with watchtowers and say, well, you had your state backed up with a watchtower, so they can't really try that. Plus, they don't know if maybe you're trying something on them. Maybe you're like trying to like goose them into publishing a bad state. So another problem is not everybody has to use the data loss protection. So LND now will actually refuse to connect to anybody who doesn't do data loss protection. They don't signal it. So another problem, though, is what if you signal it, but you don't do it exactly in the same way that we expect it to work? So potentially, you've already force closed the channel by the time that I come and ask for the channel to be force closed. In that case, I would hope that you would have retained the state about the channel so that it will allow me to sweep back my funds. But once you force close the channel, like your entire relationship with this channel is dead now. So why not just delete the information? And the way that the commitment transactions are designed is that there's a nonce that goes into the keys in the commitment transaction. And even though the to remote output is paying to a normal public key, it's paying to a normal public key that's combined with this nonce that runs through the entire commitment transaction. And so you're not able to, even with all the information about the channel, and you can see that there's this one simple public key constrained output, you won't be able to sweep it back unless the channel partner gives you back that random number. So we need to think about how do we make that more of a standard, or make sure that people are keeping that around, and also that we need to make sure that nodes are connectable again if we want the static channel backup system to work well. Okay, this is my last slide. Okay, so I heard a lot of people talking about rebalancing. So people have this in their mind, okay, my channel gets unbalanced, and then what I'm going to do is I'm going to go rebalance it. And the best way to a lot of people have in their mind that a great way to rebalance would be to do it off-chain. I don't want to do on-chain stuff. I just want to keep it all off-chain because it's cheap. So I kind of just want to run through what it means to do off-chain rebalancing. So let's say that you have two nodes, and you have node A and node B, and they're starting at the initial state. And you can see node B here, they've run out of their liquidity. But node A has good liquidity. Well, rebalancing is actually, if you do it off-chain, what you're doing is you're actually taking liquidity from somebody else and assigning it to yourself. And this is kind of like an incentive problem potentially, because what if my fee rate to go to the store is 100, and somebody else's fee rate to go to the store is 1, and and I detect that well, there's a limited number of people who have these channels to the store. So and also assume that there's a liquidity from the store. So I'm the person who has 0 liquidity, and so assume that the store can pay to me, and then also assume that I can pay to A, the node that does have liquidity. So what I'm gonna do is I'm gonna initiate a rebalance. So what I do is I, as node B, I pay to A, and I have A pay to the store, and I have the store pay to me. So that's what a off-chain rebalance is. And you can see in this state that now I have the liquidity, and the other guy, he has no liquidity. And now I'm in a pretty good position, because every time somebody tries to go through that cheap route, that one Satoshi cost route, they're going to hit that wall of 0, and they're going to have no liquidity. And it's going to fail. So then they're going to have to retry, and then they're going to come to me, and I'm going to say, oh, great, I got some liquidity for you, but it's going to cost you 100 times what it cost you before. And you also have to think that like information isn't like perfectly distributed. So you could say like a solution to this would be, oh, well, the market will realize that there's this market opportunity here. So everybody will want to like pile onto the store more liquidity, because they'll want to undercut that 100-person person. But information is not like, we're designing a private system. Nobody can really see what's going on. So you don't know who's doing a lot of business by design. So it's potential that you're kind of like marketizing that information, and you're marketizing the liquidity itself. So the reaction that I would suggest that would be a good reaction is for people to set their fees such that if they get depleted, they now have enough from routing fees to reassign capital so that they can continue to make that channel work. But it requires you to make that. It requires that the fees to now be connected to the chain fees. The routing fees now have to be connected to the chain fees, and you have to be proactive about it. So, like, a lot of times people set up these channels. They say, "Oh, I'm going to help the network," and they say, "Oh, I'm going to set my fees at 0." And as soon as the channel gets depleted, they're like, "Oh, that Raspberry Pi in the corner, it's not doing any routing. I'll complain on Twitter or something." So, we have to kind of think about ways where the network can kind of be more reactive, and like that you get an incentive when somebody depletes you, that you have an incentive to make the situation more balanced.